Because today we are looking at an absolutely massive, completely unprecedented leap in AI capabilities. It's a shift that literally has the entire cybersecurity world both deeply fascinated and honestly profoundly concerned. We're going to dive into exactly what Anthropic's new AI model, Claude Mythos, can actually do and break down the immense potential risks it introduces to the digital infrastructure we all rely on.
Anthropic just dropped a new AI model, and honestly, it's kind of terrifying. That quote perfectly captures the vibe right now. That is the exact sentiment you're hearing echoed all across the low-level security research community. For the longest time, the idea of AI completely upending cybersecurity, it was mostly just hype. But guys, that era of dismissing AI as a toy in cyberspace is officially over. The threat is fully awake now, and as you'll see, the numbers absolutely back it up. All right, so Section 1, the AI cyber threat awakens. So we really need to reset our expectations here because all of our old assumptions about what AI can and can't do in software security, they're actively being shattered. Historically, if you asked an AI to find a bug, it would just hallucinate, right? It would make up fake vulnerabilities, spit out useless code, and basically just spam bug bounty platforms like HackerOne with pure nonsense. It was just a nuisance, definitely not a real threat. Well, Anthropic's new models have completely rewritten that reality.
Just listen to this. When tasked with writing an exploit for a known vulnerability in the Firefox web browser, the baseline model, Sonnet 4.6, sat at a totally unimpressive 4.4% success rate. It mostly just gained minimal control over a CPU register. Opus 4.6 bumps that up to a respectable 14.4%. But then we get to Mythos. It jumps to a staggering 72.4% success rate. I mean, wow. That is not just some gradual, iterative improvement. That is an exponential explosion in capability. It's gone from writing basic, clunky proofs of concept to reliable, successful remote code execution. Moving on to Section 2, the Mythos capabilities leap. Look, writing exploits for known bugs is one thing, right? But what Mythos is doing autonomously in the wild, that's what truly elevates this to a completely different class of threat. We're not talking about your basic 1990s style stack smashing to overflow a simple buffer. Mythos is executing highly complex, modern attack chains entirely on its own. It's writing advanced memory maneuvers like just-in-time heap sprays just to escape security sandboxes. It autonomously gained full control of a secure server by chaining exploits over 20 network packets. It even found a vulnerability in a highly secure, memory-safe virtual machine, presumably written in Rust, by exploiting this unavoidable, unsafe keyword block that was required to interact with raw hardware memory. It's just wild. And it gets crazier. Mythos isn't just exploiting known vulnerabilities anymore, it is actively hunting down 0 days. We're talking critical flaws that are completely unknown even to the people who wrote the software. In testing, it proved capable of finding 0-day vulnerabilities in every major operating system and every major web browser with almost zero human guidance. Perhaps the most shocking detail? It found a bug in OpenBSD that had been sitting there totally undiscovered for 27 years, almost 3 decades. It also discovered a 16-year-old vulnerability in how video streams are parsed using FFmpeg. Now, this is crucial because it represents a massive shift in human limitations versus AI. Normally, a human researcher has to be unbelievably specialized. To find a bug like this, a human would need deep knowledge of memory corruption theory, plus an exact understanding of the massive FFmpeg codebase, plus the highly specific mathematical structures of H.264 video streaming. AI simply doesn't have that bottleneck. It just effortlessly bridges the gap between understanding obscure system architecture and knowing exactly how to exploit it.
Which brings us to Section 3, Project Glasswing Explained.
So the big question is, what do you do when you've just created a machine that's capable of systematically dismantling global software security? Well, you bring in the heavy hitters. Enter Project Glasswing. This is Anthropic's highly targeted collaboration with the massive companies that literally build the world's critical infrastructure. We're talking Cisco for network stacks, NVIDIA for GPUs, Microsoft for operating systems, Broadcom for Wi-Fi controllers, VMware for hypervisors, the whole shebang. Anthropic is providing these specific organizations with Mythos-class models so they can audit their own software and fix these bugs before anybody else finds them. It is an absolutely vital step for the sake of global security. But of course, here is the plot twist, and it's catching Anthropic quite a bit of flack right now. They've stated they do not plan to make the Claude Mythos preview generally available to the public. They're locking it behind closed doors.
And frankly, when you think about it, giving literally anyone with a few dollars, regardless of their skill level or moral compass, a magic button they can press to find remotely triggerable vulnerabilities in global infrastructure, yeah, that is undeniably a terrible idea.
Let's dig into that in Section 4, Asymmetry of Cyber Warfare.
Now, some people in the community argue that locking the model away actually hurts independent defenders who could use it to secure their own code. But to really understand Anthropic's restriction, we have to look at the fundamental math of cybersecurity. The crucial point here is a massive fundamental imbalance in this space. Defenders, they have to be right 100% of the time. They have to patch every single hole, secure every endpoint, and anticipate every single attack vector. But the attackers, they only need to be right exactly once. They just need one single obscure 27-year-old bug to slip through the cracks. If a model like Mythos went fully public, this asymmetric nature means the attackers would inevitably win far, far more often than the defenders.
Section 5, the Multiplier Effect. So, while keeping the model restricted makes complete sense for global safety, it does create a very strange new reality. Right now, only giant tech organizations have access to this automated remote code execution finding capability, and that capability is immense. Think about the number 100. That is the multiplier we are dealing with here. Today, a single individual with a security mindset, maybe a few $100s of AI tokens, and access to a capable model can act with the bandwidth of 100 highly specialized security researchers. They can spin up 10 different AI agents to simultaneously run sophisticated threat modeling on entirely different software stacks. The talent density problem that has plagued cybersecurity forever, it's effectively been solved by AI.
So, what's actually at risk in this new multiplier landscape? Well, surprisingly, it's not the obvious stuff. Highly audited code bases, like the default configurations for Windows 11 or Apache Nginx, they're likely safe because the entire world already scrutinizes them nonstop. The targets at the absolute highest risk fall into two distinct camps. First, esoteric critical infrastructure. Think of the code running water pumps or electrical grids, stuff that rarely gets audited by top-tier security talent. And second, high-churn code bases like Google Chrome or Firefox. In those projects, standards constantly change, the codebase is incredibly massive, and new code gets merged every single day. And obviously, more code changing faster simply means more vulnerabilities for an AI to catch.
Section 6, WWI Trenches to a Secure Future. We are literally standing on the precipice of a totally new era in computing. And let me tell you, the transition is going to be incredibly turbulent. This massive shift happens in 3 steps. Step 1 is where we are right now, a world full of vulnerable, human-written, unaudited code bases. Now, skip to step 3, the long-term future. It's actually very bright. With AI models constantly auditing code and the rise of memory-safe programming languages, software will eventually become incredibly secure. But step 2 is the danger zone. It's what security researchers are calling the World War I trench era of cybersecurity. This is the messy, chaotic in-between period where AI tools are just accessible enough to heavily empower attackers, but our codebases haven't yet been fully secured by defenders. It is going to be an era of constant, brutal, automated hacking.
Which brings us to our final thought for this explainer. The AI cyber threat isn't just some plot for a science fiction movie anymore. It is actively tearing through decades-old code today. As these AI capabilities continue to scale, the fundamental fabric of our digital world is going to be tested like never before. So look at the software you rely on every single day. Look at the digital infrastructure powering your city, your life, and ask yourself, are we truly ready for the WWI trenches of cyber warfare? Thanks for joining me on this explainer. Make sure to keep your systems updated, and I'll catch you in the